Hi. Moving on to the second video of probability. Moving on with question number 8. I finished question 1 to 7 and the review, small review on probability, the 3 points of probability. So you can check the video 1 on probability. I'll move on to question number 8. Okay. A biased coin is flipped 6 times. So biased is not a standard coin, meaning it has some kind of a flaw. So the flaw is out here. Uh, and an unbiased coin has a probability of head equal to that of tail, which means it'll be zero point 0.5 for head, zero point 0.5 for tail. This is a biased coin. So the probability of head given is zero point 0.2 and the probability of tails given is zero point 0.8. Now this coin is flipped 6 times. So now remember that if you flip one coin 6 times, or if you flip 6 coins together, the outcome is gonna remain 2 to the power 6, which is 64 outcomes. Okay. Now the question asked is find the probability of exactly 3 heads and at least 1 head. Now, if you just quickly go through the previous question, it was a fair coin, meaning an unbiased coin. And this time, the probability of head is equal to that of a tail. So in the previous video, I've solved exactly 3 heads and at least 1 head. So this one takes you one level above the previous level. Okay, so what is this one level above? Let's have a look at it. Yeah, so you know that when you flip a coin 6 times, yeah, or you flip 6 coins together. So this is coin one, two, three, and coin six. Okay, like that. So the outcomes are all H's, all T's, and you can have one tail and all H's, etc. Yeah, and like that you have 64 total outcomes. That is 2 to the power 6. Remember, if there were 5 times, meaning a coin is flipped 5 times, or 5 coins are tossed, then the outcome is 2 to the power 5. But we are not looking at it, we are looking at this one. Okay. Now, question A is exactly 3 heads. Find the probability that it's exactly 3 heads. So for 3 heads, you will have this combination, 3 H's and 3 T's. Okay. Now, I would like to use the word arrangement out here rather than combination um, because whether you have 3 H's and 3 T's and 3 T's and 3 H's, that's a different, the order is different. So I would not like to use the word combination out here. I would like to use the word arrangement, because this arrangement of 3 H's, 3 T's, and 3 T's and then 3 H's are there different combinations and so on. HT is also a different combination, and TH is also a different combination. So I mean different arrangement. Okay. So first of all, what we need to do is, like in the previous question, we need to find out there are how many such arrangements of 3 H's and 3 T's out of the 64. Out of the 64, there are how many such arrangements? So when I did counting and combinatorics, that is the previous topic review, yeah, counting and combinatorics. So I explained permutations and combinations, along with I also explained arrangement of the letters. So under the arrangement of letters, this concept out here comes in. So there are letters, so 6 factorial, and then to get rid of the repetitions, it will be 3 factorial by 3 factorial, like that. So again, the repetition, I'm not going to explain it out here. I'm just going with the flow. So these are the number of arrangements you have of 3 H's and 3 T's out of the 64. Okay. So again, what is factorial and all? You need to know that. So I'm not going to break it down from here. Okay. So now let's consider one such arrangement. Let's consider 3 H's and 3 T's. For this arrangement, yeah, the probability that comes in the picture is for H, it is zero point 0.2, which is 1 by 5, and that is 4 by 5, zero point 0.8. So zero point 0.2 is 1 by 5, 1 by 5, and 1 by 5. So in a way, 1 by 5 cube. And similarly, you have 4 by 5, 4 by 5, and 4 by 5 for the t's. Yeah, probability of tail. So 4 by 5 cube. And you multiply that. And this is for one such arrangement. Now, how many such arrangements are there? That many. So multiply it with 6 factorial, divide by 3 factorial and 3 factorial, and that's your answer. Got it? Now, what would it be if the coin was unbiased? So in an unbiased situation, you simply would divide this by 64. Yeah, it's messed up. I'm sorry, but you'd simply divide this number by 64. You'd get your answer. Or if you want to solve it with this concept, with this one level above our concept, then you simply take half, because in an unbiased coin, what you have is you have half is the property of head and half is the property of tail. So you'll have half, half, half for three edges, half, half, half for three tails. So it's half cube into half cube. So that's nothing but half to the power 6, which in a way is nothing but 2 to the power 6, 64. And that's the reason you divide by 64. But this one, if you want to do it in this manner, you simply multiply it with the number of arrangements of 3 H's and 3 T's. So that would have been the answer if it was an unbiased coin or a fair coin. Sorry for my handwriting. Yeah. Got it, guys? So that's my answer for this one. Okay. Not that one. That one's for if it was unbiased. So now you can solve this question, pause the video, or just continue with the flow and see how I solve the part B. At least one head. So like in the previous question, at least one head, I solved it in this manner, right? So at least see out of the 64 outcomes that you get, yeah, at least one head means one head, remaining tails, two heads, remaining tails, three heads, four heads, five heads, like that. And then you get all six heads. Yeah. But there's one outcome which is all tails. Correct? There's one outcome which is all tails. And this one cannot be said comes under the category of at least one head. So find the probability of this and subtract it from one, and that's your answer for at least one head. It's simple. Yeah. Otherwise, what you have to do is you'll have to first take one head and then all tails. Find the probability of this. Okay, let's call it A. This is the probability of this. Yeah, then you have to take two heads and four tails, and then take the probability as that as B. Then take three heads and three tails, and that's C, and C is also the answer for A. And then you have four heads and two tails, and then you have five heads and one tail, and then you have all heads. So what you need to do is basically add these up, A, B, C, D. So you add them up, the total will be your answer. And the easier way out is using this strategy, this concept. Find out the probability of all tails. So all tails is nothing but 4 by 5. Yeah, 4 by 5, 4 by 5, 4 by 5 to the power 6. Remember, the number of arrangements of all tails is only one. That is 6 factorial by 6 factorial, or just write 1. That's your answer for the probability of all tails, and subtract that from 1. And this whole answer that you get will be the answer of this together. Like the sum of this is equal to that. Got it? Okay. So that was simple. Now, as an exercise, what you could do is just to do some calculation work. Yeah. Find out the answer for A, B, C, D, E, F, add them up and see if it, equals to this one, 1 minus 4/5, the whole power 6. Yeah. Question 9. Moving on to question 9. A standard die is thrown at random. Find the probability of the following. An even number on the face of the die. Now, once again, remember, die is singular, dice is plural. Yeah. More than one is plural. Dice. It's called dice. Die, singular. Now, any die, yeah. Now, remember, I am used to saying dice. So even if I'm talking about a single die, I'm going to use the word die. So just bear with me for that one, yeah. So, so if you've got a dice, yeah. So remember always that the opposite faces, yeah, will have a sum of seven. That's the normal industry standard, yeah. Opposite faces have a sum of seven. So opposite one is six, opposite three is four, opposite two is five. So like that, you have these six faces. Anyway, a standard dice is a fair dice, yeah, is thrown at random. Find the probability of the following an even number. So it's just a single dice, an even number on the face of the dice. So there are one, two, three, four, five, six. These are the, numbers showing up on the face of the dice, yeah. Not exactly one, two, three, four, five, six, but those small dots that you see, but we'll just call them as numbers, yeah. So an even number is 2, 4, and 6. So remember my sample is 6 and my event out here is an even number. So that's 3. So the probability of getting an even number is half. Okay. And therefore getting an odd number is also half. So that was very simple, half. Okay. 3 out of 6. An even or a prime number on the face of the dice. Okay. Now, such questions, you could use Venn diagram concept and solve it. Yeah. So I've done Venn through the grid method in the topics review. So there are so far I've done only four topics, yeah, which is probability, counting, and combinatorics. Grid method, which is more like the Venn diagram, but I've not done the three circle Venn in that. Yeah. Also, there is one more topic I reviewed, which is allegations, which is mixtures. So for four topics. So I think next one I'm going to do is geometry because I did see a simple rhombus question come up. Yeah. So I'm going to do geometry, in detail, along with solid geometry in for my next video. Yeah. And in the sense after completing the probabilities review. So for my next review, it'll be geometry and solid geometry. Right. So I don't know how I digressed to that, but yeah. So yeah, of course, this question, even or a prime number. So I'll just show you why the when part came in. So here's set of even numbers, set of prime numbers. Let's call it P and E. Yeah. So I know this would be, you know, E would be one, two, three, four. I'm sorry, two, four, six. Yeah, and prime would be two, three, five out of these one, two, three, four, five, six. So 2, 4, 6, and 2, 3, 5. So 2 is the common one. So you got 3 and 5 here, and you got 4 and 6 here. So if you simply have to count, the event out here is 1, 2, 3, 4, 5. So 5, even number, or they're saying a prime number on the face of dice. So that's more like E union P, which is E or P in your Venn diagram language. Yeah. So you got 5 and out of 6. So that's your answer, 5 by 6. Yeah. You can simply just write down 2, 4, 6, 2, 3, 5. 2 is already counted here, so don't count here, and that's 5 out of 6. That's how you can do it. Okay. Let's complicate matters now. Moving on to the 10th question. Right. Two standard dice are thrown at random. So, yeah, just like we had the coin outcomes, like, if there's one coin toss, then two outcomes, two coins tossed, then there are four outcomes, so on and so forth, like that. So in case of a dice, one dice rolled is six outcomes, two dice rolled is six square, 36 outcomes, and so on and so forth. Three dice rolled is 216 outcomes, and so on and so forth, right? Yeah, so just remember this basic. So two standard dice are thrown at random. Find the probability of the sum on the faces of the dice are even and prime. Okay. So एक minute. Let me just go back. I'm sorry. Let me just go back out here. Even suppose यहाँ पे और नहीं होता था और and होता था. So if it was even and prime, okay. So in that case, your answer would have been 1 out of 6 because if you remember, 2 was the only one which was even and prime, or even intersection prime, in the Venn diagram language. So that would have been 2. Got it? Yeah. So 1 out of 6 would be the answer if it was and. Anyway, sorry for digressing again and again. Let's move on. So some on the faces of the dice are even. Some on the face of the dice are even and prime. Some. So see, there is a shortcut. I'm not going to reveal that right now because I'm going to reveal it in the tougher question, which is this one. Okay. So first we'll go through the typical method 1 1, 1 2, like that 1 6. Okay. These are the, whenever you roll two dice, these are the outcomes you can get: 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1 up to 2 6, 3 1 up to 3 6, and like that 6 1, and then 6 5, and then 6 6. So like that you have 36 outcomes. Okay. So these are the pair of numbers that show up whenever you roll two dice. Now some on the faces of the dice are even and prime. Okay. So you already know that in prime numbers, as properties of number system, yeah, the only number which is even and prime is number 2. Rest all of them are odd. So if you were to discuss a set of prime numbers, all of them are odd except the first number, which is 2. 2 is the only even prime number, rest all of them are odd. So when they talk about sum on the faces of the dice are even and prime, yeah, then that's that the sum is only 2, and therefore it is only 1 and 1 that comes in the picture, and therefore the outcome out here is 1 by 36, because a sum of 2 is only got when both the numbers on the dice are 1 and 1. Okay, now you can pause the video and solve B. Sum on the faces of the dice are even or prime. Okay, so almost 90% of you will be working it a particular fashion. 10% of you will be working with the shortcut, the trick which I am going to solve now. Okay. So um, I'll just start with the solution for the second one. So I'm not going to use this idiotic way of writing 1 1 up to 6 6 and then waste my time. I'm simply going to use common sense, and the common sense is that whenever you roll two dice, yeah, the sums that you get are either 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. That's it. Understood? Whenever you roll two dice, you get maximum 12 or minimum 2 and all the numbers in between. Now, all you got to do is focus on the question. It says sum on the faces of the dice are even or prime. Okay, right? So I'm not going to again waste my time. Okay, I'm not going to find out, okay, 4 के लिए 1 3 है, 3 1 है, 2 2 है. These are the outcomes for 4. 1 1 is the outcome for 2. I'm not going to waste my time doing that. I'm going to just strike out. पहले even strike out करता हूं मैं. Okay. Now prime numbers. So prime numbers are 3, 5, 2 पहले से cancel है. 7, 9 is not even nor prime. 11 is prime. So if you see, the sum on the faces of the dice are even or prime. Yeah. If you see, all the numbers are taken in the A union B set except 9. So just for clarity purpose, if I were to draw this set, yeah, okay, the sum on the face of the dice are even or prime. So this one will be here, and this one 3, 5, 7, 11 will come here, and 4, 6, 8, 10, and 12 will come here. Understood? So what is coming out of the universal set, I mean, sorry, out of the A union B set is only 9. So, so I just need to find out the combinations that give me 9. All right. So that is 3 6, 6 3, 4 5, 5 4. So out of the 36 outcomes, only 4 are not coming within A union B. The remaining are. So my answer is 32 by 36, 8 by 9. Got it? Okay. Right. So I'll, I'm sorry, but there's one little point I want to talk about. So my answer was 8 by 9 or 32 by 36. So what I want to draw your attention out here is to the fact that um, you know, some on the face of the dice are even or prime. Suppose the question is some on the face of the dice are not even or prime. Understood? Then the answer would be 1 by 9. Okay, 1 by 9. 4 out of 36, 1 by 9. So not even or prime does not mean even and prime. Just want to draw your attention to the fact that not even or prime does not mean even and prime. Understood? Yeah. So do not make such mistakes. Okay. Not even and prime does not mean even or prime. I'm not writing it down. Just go with the words. Write it down if you want to. Not even and prime. Matlab, in the Venn language, this is not, okay, even and prime intersection भी मैं लिख देता हूँ, okay, does not mean A union B. ठीक है? Yeah. And similarly, not A union B does not mean A intersection. Remember these things, yeah? Anyway, moving on. Question 11. If a card is drawn at random from a pack of 52 playing cards, find the probability of the following. Okay. So remember now, for those people who have not come across playing cards, so playing cards come with 52 cards where there are four suits. Okay. Kali, which is spades, Chattai, Charkat, whatever, which is diamonds. Yeah. Then there is clubs, which is Fali. Yeah. And then there is Lal, which we call hearts. Lal ka Badshah, something like that. So hearts. So hearts and diamonds, they are red in color, and spades and clubs, they are black in color. Now each suit are 13 in number, and that's how 13 for the you get 52 cards. Out of these 13, three are face cards: Jack, Queen, and King. So in each of these 13, there is Jack of spades or spades of Jack, Jack of spades, Queen of spades, and King of spades. So like that, there are three face cards. They have face. If you don't, just look up the internet, and you'll come to know about what the Jack, Queen, and King looks like. The ace is not called a face card. You might call it a picture card, but that controversy we're not going to bring in here. So I'm just going to not talk about face cards and picture cards. Just call them Jack, Queen, and King. Okay. So that's the layout. Moving on. So if a card is drawn at random, so there's one card drawn at random, find the probability of the following. Now, if I've not used the words explicitly um, um, with replacement, without replacement, any of that sort, then understand that it is without replacement. Matlab, I've pulled out the card from the pack. I'm not putting it back. I'm not putting it back. I've just pulled it out. That's it. मतलब कार्ड ड्रॉ किया तो अभी 51 कार्ड अंदर है 51. ठीक है. So card is not random from the pack of 52 playing cards. Find the probability of the card of the following. The card is an ace. So we use combination. So again, go through my video on counting and combinatorics. Yeah. So 4C1 ways of selecting an ace. And how many ways can you select one card out of 52 cards? 52C1 ways. So the probability is 4C1 upon 52C1. Okay, so I'll repeat. um, we use the second golden rule or second important rule of probability out here. That probability of an event is favorable outcomes upon total outcomes. So total outcomes always work with that first. So total outcomes out here means if I am drawing a card at random, yeah, how many ways can I do that? So 52C1 ways of drawing a card at random. Now the probability of event. So just for your understanding, this is probability of favorable outcomes here. I'm sorry, not probably. This is probability of an event. Okay, I'll just write it down. Probability of an event is favorable outcomes upon total outcomes. Got it? So always write down total outcomes first. So how many ways can I select one card out of 52 cards? 52C1 ways. How many ways can I get the favorable outcomes? That is 4C1 ways because there are, remember, four aces. Yeah, so this is one more thing I forgot to mention. Because there are four suits, there'll be four aces. Okay, one for the spade, one for the club, one for the heart, one for the diamond. So like that, four aces. And so out of 52, there are four for each of them. Each of the 13 cards have four of them with different suits. So anyway, so favorable outcomes. How many ways? Well, find the probability that the card is an ace. So there are four aces. How many ways can I select one ace, which is my favorable outcome? 4C1 ways. Okay. Now remember, some of you are getting bored because you've already done probability in your 12th, yeah, or your 10th maybe. And this is for those who have not touched math for a long time, yeah, and who want a detailed understanding of these things, but in you know, a refresher way, a kind of crash course way, yeah. So obviously, I'm not doing that with each and every question. Just the first one, A, I was explaining this part in detail. So moving on, I'll just solve the question. So the card is a king or a queen. So again, this is my answer for the first one. Now, king or a queen, or meaning plus, remember that. So again, I've drawn a card at random. So total outcome is 52C1. Favorable outcome is a king or a queen. So 4C1 plus 4C1. That's my answer for this B part. Okay, that's my answer for the A part. Now the card is a face card. Yeah, I brought the controversy in it. Okay, so anyway, so I already told you Jack, Queen, or King. So if it's a face card, remember they're not talking about a Jack, they're not talking about a Queen, they're not talking about a King. So remember there are 12 face cards, four for the Jack, four for the Queen, sorry, four for the King. So 12C1 favorable outcomes, 52C1 because they don't care whether it's a Jack, Queen, or King. They're just saying it's a face card. So 12C1 upon 50C1. But remember, this is a controversy. Just leave it out because some people will consider ace as a picture card or a face card because it does have some picture on it. Yeah. So anyway, so that's your answer for the C. Then D, the card is not an ace or a queen. Interesting question. Now, what do you do? How do you solve this question? The card. So first of all, write down your total outcome 52C1. Yeah. The card is not an ace or a queen. So that means it could be any of the remaining 52 minus 52 minus 8 cards, right? These 8 would be the 4 for the aces and 4 for the queens. So therefore my answer will be 44 C1 because I don't care. It could be anything out of the 52, but it should not be an ace. It should not be a queen. Therefore, the card is not an ace or a queen. Now, this one definitely would fall under the category of not A union B, like that. Anyway, we're not going there. We're not going there. So just remember, out of the 52, subtract aces and queens. So there are 8 of them. So 44 remains. That's my answer for delta. The card is an ace or a red card. Okay, this is interesting. I'm gonna delete everything else and just focus on E now. So ace, there are 4 aces. Okay, remember that. Yeah. Or meaning plus a red card. A red card meaning there are 26 red cards. 26 reds and 26, four aces like that. Now remember, I told you that these four aces are ace of spades, ace of clubs, ace of hearts, ace of diamonds. So यहाँ पे already there are two reds involved, one for the diamonds and one for the hearts. Yeah. So out of 26, you're gonna subtract two and consider 24 reds out here because remember I've already included. Or again, you can use the help of when and say these are aces and these are reds, and then obviously there are two of the aces which are reds. So therefore, out of the 26 of reds and four of aces, two are here and 24 are here. Okay. Okay. So 24 plus 2, 26 and 2, 28. But my bad. Hang on a minute. 26 reds, right? And four aces. So 26 reds. Huh. Correct. So 24 plus 2, 26 and 2, 28. So like that, I have um 24 plus these four, 28. Yeah. So I think the Venn diagram makes it very clear. Writing it directly, you might make mistakes. So yeah, use the Venn whenever possible. So you got 24 and plus 2, 26, and then 2, or you could go from left to right, 2 for the 4 for the aces, and then 24 out here. Anyway, so 28 C1 upon 52 C1 is your answer for E. Don't forget to subtract 2. Yeah, good. Moving on then. Perhaps I think I should stop here. Question 8, 9, 10, 11. Let me see what's the time. Hang on. Hang on. So pause the video. Right, guys. As you can see, I'll stop here. 8th, 9th, 10th, 11th. Yeah. Because if you see this question number 12 has four options underneath. Yeah. A, B, C, D. And it'll just drag on to another 10 minutes and it'll make a longer video. I'll keep my videos short. Like, I don't want to really go about 40 minutes. Yeah. So I'll stop here. Okay. I mean, I have gone about 40 minutes in some videos. You can watch them, but yeah, I'll stop here with this one and I'll take it up in the next video, like video number 3. Hopefully I try to finish 12, 13, 14, 15, 16, 17 in the next video. Yeah. That's it. I'll see you in my next video. Thanks.